Okay, so as you're getting signed in, guys, okay, as I said before there, it will be in the class work folder. It'll actually also be in the stream because they just posted it. Okay, so if you go to Science 10 AP, okay, you can see I posted a new assignment, Properties of Compounds Lab. Just click on that, okay, and you'll see the videos, okay, so this one is the observations video, this first one, the one that's 25 minutes long, okay, this one here, the 36-minute one is the one I'm about to do, okay, so it's just been pre-recorded, okay, and then this 3-minute one is just a short blurb about the analysis and the conclusion, okay, so all things that you could watch while you're putting your lab report together, okay, I've been doing this for as long as I can remember, okay, and what I've heard from students is that what they find works best is if they're playing it and working on their lab report, okay, so they listen to what I say about the design, they go through their design, they pause it, they go through their design, okay, they listen to the hypothesis, they pause it, they go through their hypothesis, okay, when you're putting your lab report together, it's like you're getting the instructions all over again, okay, and you won't miss anything that way. Okay, now, if you're paying close attention and typing as we go today, okay, you'll get quite a bit of what you need, but you can always double check it. Okay, now, am I saying you have to sit there and watch another 41 minutes worth of YouTube of me going blah, blah, blah? No, okay, you can obviously scrub through some of it if you need to, okay? And in fact, I'm gonna replace it with the one I do today, which will probably end up being a little bit shorter, okay? All right, now, what you need to be in is the Google Doc. Right here, okay, it'll say your name, okay, and properties of compounds. So if you click on that, okay, it will open up the Google Doc that you are going to do all your work in and that you are going to hand into me. Just so you know, this is the only file I will accept turned in. Okay, it has your name on it, it is your Google Doc. I can go back in the revision history and see what you did. I know that sounds creepy, but I do it, okay? So make sure that this is the file you hand in. If you submit to me a PDF, I'm not going to mark it, okay? Because I can't go back in that PDF and kind of see what you did for work. It's kind of the way I make sure people haven't just copied and pasted from somebody who's taken this class in the past, okay? Everyone follow me there? Okay. All right, so our problem, okay? That's the first thing we need to write in there. Is everybody signed in, ready to go?
My password doesn't work.
Okay, are you sure it's right?
No.
Okay, come on, let's just double check it. Oh, I should pause that recording. Otherwise it will be 30. All right, so for our problem, okay, we want to restate our problem in our own words. So here's what we're trying to do. We're trying to find out whether we can use the physical properties of unknown compounds in order to determine their identity. Okay, we're going to see if it's possible to determine the identity of a bunch of unknowns based only on their physical properties. That's the point of this lab. So it becomes the problem. Okay, what are we trying to do? Okay, well, we're probably trying to do something like use an experiment to determine physical properties, which can then be used to determine the identity of unknown compounds. Okay, you can write it basically any way you want, as long as it's something about identifying unknown compounds using only their physical properties in the form of a question, just like in Jeopardy. Okay? So what we're trying to do is determine the identity of unknown compounds using only physical properties. Find a way to put that in the form of a question in your own words. So if we're looking at how this works, oh, I can't open that one. If we're looking at how this experiment works, because we want to identify our variables here, okay? So I'm going to kind of outline how the experiment is going to work, and then we'll determine what our manipulated, responding, and controlled variables are, and then you can do the explanation, okay? So at the front of the room, there are going to be 12 unknown compounds labeled A through K, okay, at the front, all right? And what you are going to do is, first off, you're going to come up and get all of your materials, okay? You're going to come up and get your depression plate that I showed you the other day, Okay, and you're going to get your thermometer and your pH strips and your conductivity apparatus and your wash bottle. Okay, the wash bottle, by the way, contains distilled water. Okay, so it is for things like rinsing off your equipment between tests, and also it is the source of the water for your solubility test. We'll just squeeze the water from the bottle into each depression and see if the substance dissolves from there. Okay, so first you come up and you'll get all of your equipment. Then you will send a group member up to get samples of each unknown. Obviously you can only do 6 at a time because our depression plates only have 6 depressions. Okay, so you come up and get like the first 6. And at that point, you will very simply note their observable physical properties. Okay, it's the first and most important test that you will run. Okay, so let's say you're just looking at substance A. You're going to look at substance A and, okay, it's a white crystalline solid with very small, fine crystals that are kind of like shards. Okay, they're not even like square. Okay, they're kind of like pointy. And it doesn't seem to have any discernible odor. That's about it. That's about what I can observe, right? I can observe that it's a solid. I can observe the nature of that solid. I said it was crystalline. I described the shape of the crystals as best I could. Okay, I tried to see if there was any odor. I couldn't smell anything, right? So, yeah, unless you can think of anything else that would be notable when you have it in front of you, anything that's notable is important. Okay, you would write that down. Those are simply the things you can observe by looking at it or smelling, wafting it, smelling it, okay, that kind of thing. All right, I've done all the observations I can make. That's my first test. Now, I'm going to take my wash bottle and I'm going to conduct the solubility test on that substance. Okay, to do that, I'm going to put the thermometer in the material and I'm going to begin to add water. Another group member is going to take the stirring rod and they're going to stir it as I add water. And I'm going to add the water till it's about, maybe a little more than half full. No one add too much or it starts dripping into other containers. Okay, keep stirring it. Okay, observe the thermometer. Are there any temperature changes? Okay, and here's what I'm noticing. The substance rapidly dissolves. Okay, in fact, after 1 minute of stirring, the substance has completely disappeared, which means it is, it's very soluble. I'd say highly soluble. If it disappears that quickly, okay, I'd say it was highly soluble, right? And I'm noticing that there's very little, if any, change in temperature during that process. Okay, now I've performed the solubility test. It's pretty simple. I add water, I stir, and I just watch for stuff. Okay, I keep an eye on the temperature, okay, and see if anything changes. All right, now I'm done with that one. Next thing I'm going to do is I'm going to take that fancy little conductivity tester that we had, okay, and I'm going to rinse it off with distilled water. I'm going to press the button and stick it in the solution I just made. And I'm going to record the number on the face. When I do that, I find that it has a conductivity of 8 out of 10. Okay, does that mean it's highly conductive?
Yes.
Okay. Does that also mean it's what kind of compound?
Ionic.
Probably an ionic compound. Yeah, I would say so. If you got a high conductivity, it would be ionic. Okay, all good things for me to know. Put them in my observations. Okay, last thing I want to test is pH. Okay, I have to have a solution to test pH, so I have to test it after I do the solubility test. I don't want to test it before the conductivity test. Why? Are there chemicals on the pH paper? Yeah. Yeah, if I stick the pH paper in there, I've now contaminated that sample, right? I haven't contaminated that sample up until now. Everything I've used was washed, okay? The only thing I added to it was distilled water. It's got nothing in it but water, okay? But as soon as I put that pH paper in, I can't do anything else with that sample now. That's why I have to test it last, okay? I put the pH paper in, and I compare it to the color chart on the vial. I record that number. I'm done with that sample. Okay. Question?
How do you waft it again? Do you
go to the big sample at the front?
Big sample.
Yeah, hold it,
Yeah.
waft.
Sorry, the observable properties is it's a solid and what color it is?
Right. Yeah. Okay, and that'll all be on the procedure that's supposed to be in there that I just put in there but didn't update. Okay. All right. I've tested. I've run the whole battery of tests, all of the tests on sample A. Now, I'm going to do the same thing to sample B. And I'm going to do the same thing with sample C. Okay? Okay.
Yeah, okay. Actually, wait, never mind.
You okay?
Yeah, sorry.
Okay. So, if that's what I'm going to do each and every time, what am I changing each time?
The substance you're testing.
Exactly. Every time I'm changing the substance. I'm always running the same tests, right? I'm always doing them in the same order. Okay, I'm using the same distilled water. Okay, all that's changing is every time I run the tests, I run it on a different substance, which makes the different substance the manipulated variable. You're welcome. Write that down. Okay, now your job, now that you know what it is to provide me with an explanation of how and why the unknown sample is the manipulated variable. Okay, how am I manipulating it? That's pretty simple. Okay, why am I manipulating it? Think back to what we're trying to get out of this, right? Our idea is something about unique physical properties here, right? Like everything has different physical properties. That could be part of your why. Okay, let's think about what our responding variable might be here. Okay, remember that the responding variable in any experiment is the thing that's different, or things that are different, because of what you've changed. Okay, so you're changing the substance each time you run the tests. Okay, what are you hoping will be different each time you run the tests?
Results of the test.
Right, which we would call, what are we testing for in here? It's two words that both start with P. The physical properties. Okay, so I would say our responding variable here would be the physical properties of each material. We are, after all, testing a different material the same way every single time. Every one of them should have different results to the test. Whoops, I just explained it for you. And recorded it. That's too bad. So remember, in your explanation, how it's responding, why it's responding. Okay, and I kind of gave those away. Okay, so each time it's a different substance, so how is that going to respond? What are those tests going to look like? That can be your how. Okay, your why. Well, every substance has unique something. All right, so now we want to think about how are the ways that we can make sure that this experiment is as valid or controlled as possible. Okay, so now we're looking at our controlled variables. So what are some things that we might want to do or make sure that we keep the same every time we test a new material?
The same about distilled water.
Okay, probably want to use about the same amount of water. Yep, that would be good.
Like clean tools, make sure everything's clean.
Okay, clean tools, I would say it's probably more procedural, but again, it is something we'd want to make sure we do.
Same amount of the compounds.
Yeah, that would be pretty important, right? I mean, think about this, guys. We're running a solubility test. If I heap a whole bunch of one in there so that the depression's almost completely full, I'll never get all of that to dissolve. And then in another one, I put like, you know, a couple of crystals. That's hardly a fair comparison in a solubility test. Okay, so yeah, I'd say the amount of material is probably a pretty important controlled variable.
The order that you do the testing.
Yeah, not just the order, but the tests themselves. Yeah, definitely. Okay, that would be really important to perform the same tests in the same order. Okay, a how and a why for that one. So we've got amount. Okay, we've got the role or the order and just the tests themselves. Okay.
The room's environment.
Yeah. Guys, environmental conditions can always be a controlled variable. Okay? And we know that things like solubility are affected by temperature. Okay? It's why we're going to make sure, when we could say one of the other control variables, the distilled water we're using. I'm not using, you know, hot water on one and cold water on another, and I'm not testing one thing in a room that's 20 degrees and one thing in a room that's 30 degrees. Okay, all those environmental things, if they can have an effect on the experiment, then they have to be a controlled variable. Okay, so those are the things you want to think about when you're trying to come up with 3 controlled variables for any experiment. Okay, so if you guys can just stop typing for 1 sec here. Okay, there are 2 classes of controlled variables. Okay, there are conditional, or sometimes environmental. Okay, conditional can also be environmental, and there are procedural controlled variables. And it's a good idea to have for sure one of each. I mean, you have to have 3 variables, so you're probably gonna have 2 of one and 1 of the other. Okay, it doesn't really matter, but you should have both kinds of controlled variable, and we've done that. One of our procedural variables is the tests and the order they're being done in. Okay, our other procedural variable was the amount of material, okay, that we were going to use, and one of our conditional control variable could be temperature of the water, okay, things like the temperature of the room, all of that kind of stuff. Okay, you guys go back to typing, give me explanations of how and why for each one, okay, because each one is controlled differently, so they each get a how and a why. Okay, give you a few minutes on that one. Okay, so while you're typing there, just to give you an idea of the level of detail, if you recall I said that earlier, level of detail is important. Okay, the level of detail I'm looking for here, each one of these variables should have a couple of sentences, okay, worth of explanation, right? You're identifying it, you're explaining how, you're explaining why, that probably comes out to 2 pretty good sentences, okay? If you're just saying, the substances, because we're changing them, yeah. That's not really very good, okay, to be perfectly honest and blunt, okay? We want a good explanation there, good complete sentences, proper grammar and spelling and all of that. Okay. All right, so for the hypothesis, okay, remember the hypothesis is an if and then statement that first tells us what we think is true, or what the relationship between your 2 variables is, okay? It's going to make a statement about what our idea is, okay? The and part is going to briefly describe the experiment, okay, very briefly. And then the then part is going to predict the results, okay? So, our premise that we're working on in this lab is that all compounds have unique physical properties. Okay, that's what we're working on. We're saying every substance, no matter what it is, has something about it that is different from something else. Maybe many somethings, okay? But they all have unique physical properties. Okay? Should that be part of the if part of the experiment, if that's the premise we're working on? It absolutely should be. The if part is the premise. Okay? It is what we are testing, what we believe to be true. Okay? Now, I've said we and us a bunch of times. Should we and us be in your hypothesis? No. Absolutely not. Okay? So the if part will be if, and then you talk about substances having unique physical properties. Okay? There doesn't have to be an I or a we or an us in there. Okay? But our premise is that all substances have unique physical properties. If that's true, that's why it's in the if part. If that's true, okay, and an experiment like the one we're going to run is run, then what should happen?
Well, it's hard to say it without like we or us, but we should be able to tell all the compounds apart.
Okay.
We should be able to identify all 12 compounds.
Okay, I'd say that's probably going to be like the last part of the then part, but we definitely want to include that without the we. Okay? What are the results going to be? That's what we can do with the results. What are the results going to be?
If different substances each have unique physical properties, and substances are each run under the same test and observed carefully, then the substances should react differently and show different properties.
I would say that's what should happen. Okay? If what we said is true, and an experiment that tests for all these physical properties, and you can list those, an experiment testing this and this and this and this and this and this is run, then each material should, you tell me, okay? And that could be used to,
Tell the unknown compounds apart.
right,
and-
or identify them,
Or
right?
identify them.
See, you did it without we.
Yeah.
Yeah, see, it's tricky, but you can do it without we or us or I or them, okay? So, well, actually, them is okay, but not I or us. Okay, you guys got the idea here? So the if part's about physical properties, the and part briefly describes the experiment, the then part says, this is what's gonna happen, and what can be done with that. Okay, in this case, the what can be done with that is identify the unknown compounds. Okay, we definitely want to have that in there, okay? But there's got to be a little bit before that about what the results of the test are going to be, and then it's going to help to identify the unknowns. All right, give you a bit of time on that. Okay, so I've just sent the procedures to the printer here, so we'll be able to have a look at those in just a minute. But it's gonna kind of look like this, all right? So when we go into the lab tomorrow, first obviously you'll put on your safety goggles and the lab apron if you so choose, okay, all of that kind of stuff. Okay, then a member of your group, okay, because it doesn't take all of you and it gets really crowded at the front if everybody comes up, just send up a group member to grab the depression plate, the thermometer, the stirring rod, the conductivity apparatus, and the pH strips from the front table. Okay, and you go back, everybody checks out that we've got everything we need. Maybe it's a good idea to give that depression plate a little cleaning, okay, with distilled water, like wash it out, or maybe even the tap water, wash it out and dry it real good, okay, with a paper towel, because you cannot depend on other people having cleaned it sufficiently, okay? If you trust others to have done a good job of cleaning it, you're gonna be disappointed, okay? So I would say it's probably not a bad idea to give a look at that question.
Do we just like write this down?
No, I'm printing everybody a copy.
Oh.
Yeah, so everyone will get one. Okay, now I've changed number 2 so that the typed copy you get, it just says take equal amounts of each unknown, and then it says for solids, okay, take sufficient amounts to just cover the bottom of the depression. And then it follows up with for liquids, ensure that the depression is 1/3 of the way full. And that's the best we're gonna do for controlling the amount of everything. Is it perfect? No. Is it sufficient for this experiment? Yes. Okay?
So for solubility, are we only testing the solids?
Nope, you'll also test the liquids, right? If it separates, if it floats on the top,
Okay.
then it's not soluble.
Okay.
If it all still looks like one solution, then it's soluble.
Okay.
Yeah. Okay, that's a good question though. All right, and then using samples on the front table, okay, perform the observable properties test. Now, for the front table, that's the wafting. Send the one person in your group who's got the best sniffer, okay? That is not the person currently sick. Okay, I see it all the time. The person comes up and they're like literally draining into the substance. Like, don't send that person up. They couldn't smell a fart if they were right next to it, okay? Like, let's bring someone up who's got a good sniffer, who smells well, okay? Not smells good, because they could smell good and also smell bad at the same time. The person who has the best sense of smell is the person who should come up and do the wafting, okay? And then at the table, okay, because you'll have all of the substances there at the table, you can perform the other observable properties: color, texture, states, all of that kind of stuff that you think is important. You record whatever you think is important, okay? And then, yeah, waft the samples, record any other characteristics. Once you've done that for every sample, then you can move on to the solubility test. Now it says eyedropper here because we did actually used to use an eyedropper, but now we've got the wash bottles. So what you'll do is you'll take the wash bottle and you'll slowly add water to the depression with the thermometer in there, stirring constantly. So it's a 2-person job at least, okay? One person to hold the thermometer and squeeze the wash bottle, and another person to operate the stirring rod, okay? And you do that and you simply observe. Does it dissolve? Okay, if it does, you record that. Does it dissolve quickly? Is there any change in temperature? You record that. Is there a change in color? Okay, does the solution assume the color of the powder? Okay, if the powder was blue and the solution turns blue, that's notable. Okay, so all of those kinds of things should be recorded as you do the solubility test. Okay, now, how long should you wait? for the solubility test? Like, how long should you have somebody stirring there in hopes that it will dissolve?
Like, give it like 30 seconds, I would say.
Okay, I would say give it a minute, between 30 seconds and a minute. If it hasn't dissolved after a minute of stirring, it's not going to. Okay, because I have people and they'll literally sit there stirring and stirring and stirring, then the bell will go and they're, well, it's still doing the solubility test. Well, you waited too long. Okay, that stuff is not going to dissolve. Okay, give it a minute, give it good stirring. Okay, things to watch for, because you might not get all of it to dissolve. But if some of it dissolves and the crystals, you know, if the edges have rounded off and it's shrunk, okay, those are all signs that it's soluble. That the water taking on the color, that's also a sign that it's soluble. Those are all things to watch for. Just because you don't get all of it to dissolve doesn't mean it's not soluble. Okay? Now, if you get nothing happens, or it's floating on the surface, and no matter what you do, it always ends up back on the surface, it's not shrinking, it's not changing at all, then it's not soluble. Okay? I think you guys will know the difference when you get to it, but okay. We're using fairly small amount of water for the amount of substance we're going to have, and we may not get all of them to completely dissolve. Okay? But if you see that the crystals are shrinking, there's less of it than there was when you started, okay? If there's been a color change or anything like that, then yes, it's soluble. Okay? If there's a temperature change, it's definitely soluble. All right? Making sense? Okay, so that's what you watch for that. Okay? Then you're going to do the conductivity test. That's probably the easiest one. Okay? Give it a little rinse with the wash bottle, push the button, stick it in there, record the number. Okay? And then for the pH test, okay, take a piece of pH paper off of the thing, cut it, or like tear it in half, and use one for, you can use one strip to do two. Okay? Now that one has to be immediate. You put it in and you compare immediately. Don't wait. Okay? Put it in, compare to the chart, throw it out. Don't get any on your fingers. Okay? That is any of the material, not the pH paper. Obviously, you're touching that with bare hands.
And if it does not dissolve like at all, do you just dip it in the water that
Yep.
hasn't
You
dissolved?
use the solution. Yeah. You'll probably get a reading of
7.
Yeah. Most of the things that we do are going to be between 5 and 8 anyway. Okay? There's only a couple that are going to be radically outside of, you know, close to neutral. Yeah. Okay. That concludes it. Then you've done all of the tests, right? You've just done the pH test. Okay. Now you can take that depression plate and you bring it up to the fume hood. Okay. The fume hood is at the front next to the table where you get your stuff from. In there is the disgust bucket. Okay, the disgust bucket is disgusting. It's full of all kinds of terrible, awful things. Okay, you're going to add to those terrible, awful things by dumping your depression plate into the disgust bucket. Okay, it does not go down the sink. Okay, some of that stuff is really, really bad, and we don't want it in the sewer system or in the river later. Okay, so make sure it goes in the disgust bucket. Bring your wash bottle up. Give it a good rinse. Then you can take it back and do the rest of the cleaning in the sink. Dry it out. You're ready for the next 6. Okay? All right. Questions on how that procedure is going to work? You'll have the procedure in front of you tomorrow so that you can do it all yourself. And we won't have the Chromebooks again, but we will talk about the analysis. This is basically just saying A was this, B was this. Now, in order to do that, sorry, I forgot to talk about that. In order to do the identification, if you look in the materials, okay, you will see a whole bunch of compounds listed there. Those are the possible identities of the unknowns. Okay, so one of those unknowns is ammonium nitrate. One of those unknowns is copper 2 sulfate. One of them is ethanol. Okay, that's the stuff that's in hand sanitizer. Okay, one of them is paraffin. Okay, paraffin is candle wax. Okay, one of them is sodium chloride. One of them is sodium hydroxide. One is hydrogen chloride. One is sugar, sucrose. One's water. Okay, one's cobalt chloride. One's nickel 2 chloride. Okay, then the scupula is the thing that you scoop it out with. Okay, all that stuff. Right. So those are the possible identities. Okay. Give you an idea of what you're going to be looking for. Questions from you guys? Okay, as you can see in Google Classroom, I made the due date, I think, next Tuesday. Okay, so you'll have a week. I generally try to give a week for lab reports. I don't always get exactly a week, but close. Okay, does that give you plenty of time to get it done and bring it in, have me look it over if you so desire?
Yeah.
Yes. Don't come in on the morning it's due and say, Mr. Coderre, look it over. Okay, I won't do that. you don't have time to do a good job of any revisions in the 30 seconds you'll have. Okay, bring it in before then, and I'm happy to look at it. Okay? All right, let's get you guys signed up. Just so you know, with our Chromebooks, these are the science Chromebooks, we're very particular about how they work. You will notice that on your Chromebook there is a number. That number corresponds to the slot that Chromebook is going to go in. You will put it back in that slot after, whoa, 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 whoa. Make sure it is shut down completely. Don't just close the lid, okay? You sign out, then you shut it down. You actually hit the shutdown, wait for the screen to go black, then close the lid. If you don't do that, you stay signed in. Okay, next person signs in. They do the same thing. Pretty soon there are 20 accounts open on that Chromebook, and it slows to a crawl, and it's garbage. So sign out, shut down, put it in the right slot, and plug it in. All right.